I think at the end of the day, and I think I already said this, a lot of people are interested, but they're still waiting. I think the sooner you get around the idea of a microgrid, the better it is for your company. I mean, you can wait a year, you can wait 2 years, but the problem is not going away. And I think it's time that people start realizing that they have to build some internal knowledge at the company so that they can deal with this idea of a microgrid and actually build it and maintain it, because it's a little bit more complicated than just purchasing the electricity from the utility. So you need internal knowledge, and I think it's the sooner someone can start actually building that knowledge, the better it is for the business and your business case, because it's just otherwise you're just deferring the problem.
Are you speeding the energy transition? Here at the Clean Power Hour, our host Tim Montague bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. Today on the Clean Power Hour, batteries and microgrids. My guest today is Michael Stadler. He is the CTO for Xendee, a design platform for microgrids specifically. Welcome to the show, Michael.
Thanks for having me.
You know, it is heady days, as we were saying in the pre-show. The market is very dynamic. Solar and batteries are all the rage, but now there are incentives for other resources like natural gas. And so you can't just rely on a single technology. You need to be flexible about what it is that you're planning. But tell us a little bit about your background. How did you come to the microgrid space? I know that you were at Lawrence Berkeley National Laboratory, but how did you get interested in this topic?
Well, I think it was more than 20 years ago that I came actually over from Europe as a student to Berkeley. And I started working in 2002 and 2003 on the concept of microgrids. At that time, I mean, not many people were really thinking about it, but we started thinking about how can you design a microgrid in an effective way from a cost perspective, environmental perspective, right? And it can be a challenging issue because you have a lot of technologies. I mean, you can have a microgrid with a gas generator. You can have a microgrid with a CHP system, combined heat and power system, right? You can have renewables in the system. So all these technologies need to work together, need to create an economic benefit, and to design such a system is really a challenge. And this is how we started more than 20 years ago. And we did a lot of research around this at Lawrence Berkeley National Lab, a lot of publications. We did all these projects also with the military, and we have proven the technology. But it was always a technology which needed students actually, or academics, to really use it. And this is why in 2018 we decided to actually start a company together with Adib, and really create a technology based on my knowledge and his knowledge, which is around power flow and distribution simulation, to really come up with a product which is helping the client in an easy way to figure out how a microgrid should be structured, what the savings are, and how we can run it, right? And this is what we started in 2018. Now, a couple of years later, we're really thriving, and the microgrid space is really changing. I mean, originally microgrids, it was mostly about PV systems, batteries, right? Then there was a couple of years ago, the electric vehicles are coming into the big picture here. But just recently, now with changes in the administration and how we see renewables, now systems are back to more combined heat and power systems, gas engines. And for example, in data centers, which are a big push of the administration here, we see now that microgrids really playing a big role. So actually, microgrids are not going away. They're actually growing. They're just becoming a little bit more complicated and have a little bit more technologies in it than we had in the past. I think that's how we see this at the moment.
Yeah. And you mentioned Adib Naslé, the co-founder and CEO. I interviewed him last year. Check out episode 209 on the Clean Power Hour for an interview about designing and optimizing complex microgrids, which is the same topic that we're talking to Michael about. But Michael, let's kind of start from the ground up. When you think about designing and optimizing microgrids, how do you start to solve that problem? What is the foundation?
I mean, of course, there are multiple steps to this, right? I mean, when you have an idea about a microgrid, you start screening it, a site or a location, right? So you have a screening process, and the data that you need for this is a little bit different than if you would design a microgrid in detail. So we have here a multiple step approach, and traditionally, when you look at this, I mean, you need some information about, if it's an existing site, how the site is operated, because you want to make sure that with a microgrid, you're running the system differently and more effectively. So you need to collect some existing information about the electricity bills, the loads and all this stuff, so that you can start actually analyzing the system and figuring out what technologies are most attractive for this, right? And you have, as I said already, a lot of different technologies that you can consider. I mean, traditionally we had PV and batteries, but what about CHP systems? What about absorption channels, which are a big play now with data centers because they can cool with waste heat? All these technologies need to be analyzed, and you need some information on technologies, right? So we also provide this information if we want to make it easier for the client and for the user to actually analyze such a system. And
let's think about a data center, because this is in the news a lot. Many gigawatt scale plus data centers are under development and construction in the U.S. now. I looked at a chart recently, and data centers for for AI are now as voluminous as all of the other internet cloud service data centers, right? So this explosion, the explosion of AI data centers is very real. And these are very large facilities. They are measured in gigawatts, right? So a relatively modest one would be 1 gigawatt, and they go up to like 10 gigawatts. So let's just talk about a 1 gigawatt data center where you want some kind of resiliency. You want to ease the path to interconnection. So perhaps you're going to design the facility to be a microgrid initially, so that you don't have to wait in a queue for 5 years to get your interconnection to the grid operator, whether that's in MISO or PJM. I mean, the queue lines are amazing. But walk us through, how does a customer leverage Xendee, and what is the outcome that they're going to achieve by using your platform?
Well, I mean, because we have such a large size here, I mean, the technologies, the different sets of technologies that you can use are a little bit limited. So it's clear that you cannot have a 1 gigawatt data center facility just with photovoltaics. I mean, that's probably an illusion. And this is why we see in these projects that It's mostly a combination between generators, batteries, and PV systems, and some market participation. So we also see, as for example, in Texas, that these data centers want to play a role in the electricity market. So the clients already have a certain idea about the technologies that are involved, right, or should be involved. But at the end of the day, they need to figure out how big the generator should be, or when should they really trade electricity on the market to benefit from this. Because at the end of the day, the data center itself doesn't want to be bothered by, oh, can I run this or no? So there needs to be a third party providing the energy as a service to the data center, and that third party needs to figure out how they make money. And for this, they need to have batteries, generators, or the market participation in the mix to actually figure out how much they can actually save money or generate electricity for a certain price so that they can offer this to the data center. And figuring out how big the generator should be, how big the battery should be, or what the potential for market participation is not an easy task. And this is what we are doing with them. And at the end of the day, when they're done, they know exactly how much they can save or how much the electricity costs or how much they should charge the data center with certain sets of technologies. So it's basically the first step is building a concept about the technologies that they need to use to achieve a certain goal, right? So that's the first step, and that's where we're helping them.
Yeah. And so when you think about in big blocks, though, a 1 gigawatt data center that has to have electricity 24/7, you could, of course, just plug it into the grid and you rely on grid power, and grid power is going to
I think you cannot. I think you cannot, because that's the problem. Because it's not an energy problem; it's a power problem. I mean, these data centers are in areas where the energy is already and the power is constrained. I mean, as you said, it takes a long time to get the utility interconnection. We have seen that this can take 8 or 10 years. So actually, there's not the option to really go with the data center, with the utility for most of these cases. So that's actually why people start thinking about microgrids, because the utility cannot handle this, period.
I love that. The harsh reality of money and what is most cost effective and time effective. And, we see a lot of news about nuclear power, for example, and SMNRs, and I've covered this topic on the show, but to build, to design, permit, and construct a nuclear power plant is not a 5-year venture. That is at least a 10 and probably a 15-year venture. If you're going to build a 1 gigawatt solar battery or solar wind and battery with some natural gas, what is the time frame and what is the relative size of those chunks of sources for the project?
I mean, every site is different, right? And it also depends on how much land you have to basically build your PV system.
Let's assume there's no constraints on land. West Texas is a big place.
Well, then it's actually a cost play. I mean, what we see is that combined heat and power units, CHP systems, running on natural gas can be very effective for data centers, and they are a big chunk in this game, because traditionally, when you have a data center, you purchase electricity to run your computers, right? But then you have to cool down the environment, so you purchase electricity again. But with a CHP system, you generate electricity, and the heat from the generator, waste heat, can be used in an absorption chiller, so-called absorption chiller, and you can cool the building. So with a CHP system, you naturally reduce the electricity demand, because you don't need electricity for cooling from the utility, right? For an electric chiller. So what we see is that basically every data center is playing with gas generators, big gas generators, to power the facility, and also provide the waste heat for an absorption chiller. Of course, a lot of these data centers also install batteries, because you can easily do backup for the system, and you can do market participation. And the PV systems are also playing a role, but reality is, I mean, in all the projects that we have seen, there's a land constraint, and this is a little bit constraining the PV system, right? But from a cost perspective, it's very effective to actually power a data center with natural gas.
And so I have a problem. Okay, I need 1 gigawatt hour of firm 24/7 power, and and then I feed that problem into Xendee. Can we think of Xendee as an AI that is then going to say, doot, 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 doot? Well, look, based on what I see in this geography, for the cost of grid power, I recommend, a 500 megawatt gas turbine, combined heat and power system, augmented with a 500 megawatt solar farm and a 500 megawatt hour battery.
Yep, that's exactly what it is. And it tells you what the rate of return is, what the cost of electricity are. So all this is output of the system. But on top of it, you're also getting an idea on how you should run the system, because installing the capacities is only one part of it. But then when you have the technologies on site, you need to run them in the right way to make the money, right? Because if you want to do market participation, you need to charge the battery at the right time, or you need to sell to the market or purchase from the market so that you make money, like in Texas, right? And when you run Xendee, you get the sizes, the capacities, as you said, but at the same time, it also tells you on how you can expect to utilize these technologies. And the nice thing about this is actually a control strategy. We are mimicking the real control strategy that will be deployed later on. And this actually enables us to take part of this algorithm and really deploy it as a controller. So our business game is actually helping people figuring out the system, the sizes, the savings, and everything. And then when they have installed the system, we also can control their technologies to really capitalize on the benefits that we have been calculating early on. So that's also an additional benefit.
I'm curious because, as you mentioned, this is a very dynamic market. Things are changing. The federal administration is incentivizing certain technologies. They're putting tariffs and other restrictions like foreign entities of concern on the ITC, the investment tax credit, on equipment made in China, for example. Does Xendee take into account supply chain and the cost of equipment issues? Because that landscape seems to be highly variable. The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more.
I mean, we are not directly modeling the supply chain, but of course, we change the costs so that they reflect those issues right in the timeline. But we are not in the business to really assess if this PV system or that PV system will take a certain amount of time to come over or get manufactured in the United States.
Yeah.
So that's not our objective.
But is it such that I say to Xendee, okay, here's the cost of solar modules, here's the cost of batteries, here's the cost of natural gas generators, and maybe a few other technologies. Go ahead and optimize the design for a 1 gigawatt hour data or 1 gigawatt data center in this geography. Is it that simple?
It's that simple to some extent.
On the front end, I know it's the rocket science is behind the screen.
But that's one point here, Tim. You're not designing a microgrid just for one point in time. And this is actually why the microgrid concept is so helpful. Because you can design a microgrid for now, and maybe now you have a gas generator and maybe some batteries or whatever it is, right? But you can think about the future, and that's how we approach this, because the data centers are growing, the demand is growing. So you can model actually the growth rates and all that stuff, the electricity price changes, the gas rate changes and all that stuff, and also the advancement in technologies. And we did a couple of those studies, and we said, well, let's start a microgrid now with a CHP system. But maybe 10 years down the road, when small modular reactors are more attractive, they can easily be plugged into a microgrid concept, right? So we are not modeling this for one point in time. We do this for multiple years because it's actually a timeline or an investment timeline on how you have to upgrade the system. And our point is, it doesn't really matter how the microgrid looks like now. Our point is you should start a microgrid now with the technologies that you have at hand, because it's always cheaper than waiting for the utility or purchasing the electricity from the utility if they can provide it. And then over time, augment the microgrid with newer technologies or just upgrade it. And every simulation that we did actually points to the fact it's always better to start with a microgrid and think about a microgrid like a fluid system which gets upgraded over time, because then you can always hedge your risk against uncertainty in the market. And that's actually the real point here. A microgrid is a concept which can help you for multiple years and not just for now.
Yeah. So is there more to say about finance and business models with regard to Xendee and the service that you're providing to developers?
I mean, there are, of course, multiple financial models on how you can approach this, right? You can do this as an energy as a service. You can model certain forms of investments, and we support our clients with this, right? But what I have seen is with the data centers, because we were speaking about this, is that they're mostly doing this as an energy as a service. So third parties basically installing the technologies, running the technologies, the microgrid, and providing the energy to the data center as an energy as a service contract. And this is what we most of the time model for our clients.
What are some other popular use cases for microgrids as far as Xendee sees them?
Military. I mean, we have done a lot of projects with the military, of course, different reasons. It's resiliency. I mean, we had a lot of projects with the US Army overseas because they wanted to become independent from gas, for example, in Germany and Italy. So we did a lot of projects there. And that's a very good use case. And still, also in the United States, military bases really changing on how they use energy and how they generate it, because they have to be independent for at least 2 weeks, right? So military sites are a big player here. What we're also seeing is communities, university campuses. I mean, traditionally, university campuses have been using microgrids for a long time. We just didn't call them microgrids because they have gas engines, they have large generators, they need a lot of steam. So combined heat and power units were always playing a role for a large university campus, right? And actually, university campuses are the largest microgrid market in the United States at the moment, right? But communities are changing now. Communities want to become more independent. We see that third parties provide energy as a service to communities to have a more diverse energy portfolio, not just getting energy from the utility. So, I mean, yeah, the electric vehicle infrastructure is also an issue. It's a little bit soft at the moment because there's not so much talking about electric vehicles at the moment. But at some point, electric vehicles will be an issue for the electric infrastructure. And now combining this with the data center issue, that data centers need a lot of power in the gigawatt range. And then you have these hyperchargers for electric vehicles, which also is constraining the infrastructure, the utility infrastructure. Then we have the perfect storm, I would say. And this is also why we were always doing projects and supporting electric vehicle infrastructure projects, because, I mean, on a highway system, I mean, in the middle of the desert, I mean, and you have a bad or poor utility connection, and you cannot charge cars there with 2-3 gigawatts, right? So you need to build a microgrid to buffer the problem. And that's another market, which is a little bit soft at the moment, but I think it will come back.
Yeah. You know, here we are in Q3 of 2025, and the AI takeoff is happening before our eyes, right? Superintelligence is on the horizon now. And I'm just curious, how does Xendee see this landscape? What is the importance of machine learning and artificial intelligence in your platform and in general when it comes to not only designing, optimizing, but running these microgrids?
I mean, of course, AI plays a role, especially in the control strategy of Xendee. So the planning tool is an optimization engine, which is not directly AI, but then when we dispatch the technologies in real time, we need forecasting. We need to forecast electricity loads. We need to forecast heating loads, renewable energy output, and we use for this forecasting in AI. But I have to say that we actually try to use AI as little as we can because it's computationally expensive. We see that too, right? I mean, if I run AI and I want to have the best outcome for a forecast, I mean, it costs money, right? And this is why we put a lot of time and energy into actually making these approaches simpler so that they can become a little bit cheaper, because otherwise it can be an issue if we have to run a specific computer for every microcontroller, which uses a lot of energy. I mean, it's not a lot compared to the AI data centers, but it can add up. And this is why we try to be a little bit more efficient on this side and make it effective, because it can add up. But of course, we also use AI for our forecasting engines.
What else, when you look into your crystal ball, do you see, whether it's on the policy front or the technology front, that's going to impact batteries and microgrids?
So it's interesting. I would say it this way. I mean, for a long time, the industry was thinking that we need a lot of subsidies in the microgrid space, and a lot of government funding went into the microgrid space. But I think we're at the point where actually it's not so bad that actually people have to start thinking about the economic value of a microgrid, right? I mean, and this is why we see more business, because people now start thinking, hey, wait a minute, I'm not getting an incentive or funding from the government. I need to do this with my own money. And this is why they are getting really serious about planning this in a good way and running them in a good way. So from my perspective, I think microgrids are to some extent a mature technology. Of course, they're different at different sites. But from a policy side, I think it's a self-run, I would say, and it's happening, and it will just grow. And I mean, as I said, electric vehicles and all this. So I think that the policy incentives are playing a minor role in the microgrid space at the moment. Of course, certain companies have a problem with this, but larger companies or companies doing this the right way will survive and actually grow. So I'm not so sure if the policies will really impact the microgrid space. That's what I'm saying.
I often tell my listeners, if they want to see the future, go to Northern Europe or Asia, because those markets are further along in their integration of distributed energy resources. What is going on in other markets that you're paying particular attention to?
So it's interesting that you mentioned this, because you are right that in Europe, and you can hear this on my accent, I'm originally from Europe, that there are certain things which are ahead of the United States. But in terms of microgrid space, I think it's actually really the US which is ahead here, because in Europe, we don't see microgrids like we see them in the United States. In Europe, it's really distributed energy resources, virtual power plants, large entities controlling this. And it's mostly in front of the meter. So basically, you have large wind farms, you have these PV farms in Germany, and they somehow get connected, which actually creates an issue for the system because it's not behind the meter. Those systems actually burden the infrastructure a lot. And this is why a microgrid is completely different than a virtual power plant or a large distributed energy resources, because a microgrid can help to reduce the burden on the public system, while a system like we have it in Germany or in the northern countries in Europe is actually burdening the infrastructure, because they need to connect these large wind farms with the demand pockets in certain parts of the country. And this actually leads to the issue that in Europe we see a big increase in cost for transmission and distribution. So energy is not expensive, but the distribution transmission becomes very expensive because everyone has to upgrade to transmission distribution lines. And this is actually why now in the United States, the microgrids can help, because we have two options for data centers. We can build the infrastructure, which is costly, or we do it with microgrids, which is actually cheaper for the society and more reliable. So in this regard, I think actually we are ahead in the United States when it comes to microgrids, because it's actually a different thinking, which is helping the infrastructure, which we don't have in Europe.
Yeah, I mean, as far as I can tell, transmission, it's both transmission and distribution are a bottleneck. The grid is already in many places at capacity. And so if you're going to build a big asset that requires a lot of power, a microgrid is a natural go-to because then it can
Exactly.
island and
Yeah.
not, lean on those already at capacity facilities. I don't understand though why that's not the case in Europe.
I think it has to do with how, I mean, it's a cultural difference and the utilities. In Europe, the utilities are way strong, I would say, and control most parts of the systems in a different way.
Mm.
And the other thing is the utility and the utility system is newer than in the United States because it got rebuilt after World War II. So Europe is not at the same stage like the United States when it comes to the aging infrastructure. So most utilities in Europe actually don't see that problem because they say, well, our infrastructure still can handle all this, right? While we know in the United States it cannot handle it anyway. It's old, it's failing, and I mean it's just a complete bottleneck, as you said. But these things we're not there in Europe, and this is why people don't see the benefits of microgrids like we see them in the United States.
Well, what else should our listeners know about Xendee and this world of microgrids, whether it's individual projects or portfolios of projects?
Good question. I mean, I think at the end of the day, and I think I already said this, a lot of people are interested, but they're still waiting. And I think the sooner you get around the idea of a microgrid, the better it is for your company. I mean, you can wait a year, you can wait 2 years, but the problem is not going away. And I think it's time that people start realizing that they have to build some internal knowledge at the company so that they can deal with this idea of a microgrid and actually build it and maintain it, because it's a little bit more complicated than just purchasing the electricity from the utility. So you need internal knowledge, and I think it's the sooner someone can start actually building that knowledge, the better it is for the business and your business case, because it's just otherwise you're just deferring the problem. At the end of the day, I don't see how we can actually build the infrastructure in the United States at low cost that can handle all this, because California already we have $1 per kilowatt hour electricity rates. I mean, now if you top this with building new infrastructure, we end up with $5 per kilowatt hour. I mean, that's not sustainable. So at the end of the day, I think my messages and my thinking is the sooner we really build microgrids, the sooner we're out of this problem.
Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. All right, well, let's wrap it up. Check out all of our content at cleanpowerhour.com. Give us a rating and a review on Apple or Spotify. Follow us on YouTube and reach out to me on LinkedIn. I love hearing from my listeners. You can find Xendee at xendee.com. But how else can people find you, Michael?
Just go to our website and xendee.com and let's see how we can help you.
With that, I'll say I'm Tim Montague. Let's grow solar and storage. Thank you so much, Michael Stadler, CTO of Xendee.
Thank you.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more.